So this second part of the lesson is on the quadratic formula, and we're actually going to start out and just talk about how would we simplify answers at the end of the quadratic formula. So these are 4 different scenarios. Okay, I left the notes up from the top part. 4 different scenarios we might see. The first one is my radical doesn't simplify, so there's nothing I can do. So this answer right here, if we saw something like this, that would be it. We would be done. If we were going to write it in set builder notation, we would have 3 minus radical 11 over 6 and 3 plus radical 11 over 6. So looking at that, it's super tempting to cross out this 3 and 6 on each of the fractions, but there is nothing. Basically, it's like there's a parentheses there because of the addition. There's nothing I can take out of that 1 radical 11 that would also cancel, so I have to leave it as is. The next possible scenario is that we'll have the radical simplify. So I notice 50 has a perfect square that goes into it. That's 25. Breaks down into 25 times 2. So we are going to take this, and that becomes a 5. So then I look at each of these terms. I look at the 3, I look at the 5 in the radical 2, and the 6. They don't have any numbers in common, like a GCF, that I can take out, so that is my final answer. So this is a little different. We have it simplified. We could write it as 2 separate answers, just like we did the last one, but we can't cancel anything. So moving on to the third one. This is 3 plus or minus. 72 has a couple perfect squares, or a few that go into it. 4, 9, 36 is the biggest one, so that's the one I'm going to use here. We always want to break it down as much as possible. So this is going to give me 3 plus or minus square root of 36 is 6, and that's all over 6. So now I look at these 3 numbers, and this is kind of like a unit. It's kind of like a 6x you could think of it as, so I can take off of that 6, but those 2 are connected. So I do have something in common between all those 3. 3 goes into each of those numbers, so I'm going to reduce each of those by dividing by 3. So this becomes a 1, that becomes a 2, and that becomes a 2. And it's only when I can take it out of all 3 of them that I can reduce it. So this is 1 plus or minus 2 radical 2 over 2. If I was going to write that as separate answers, I would write 1 minus 2 radical 2 over 2 and 1 plus 2 radical 2 over 2. And I'm kind of splitting these up randomly. Sometimes I do, sometimes I don't, just to show you that they're both correct. Okay, it's just sometimes we write it different ways. So far, no simplifying, okay? Simplify the radical can't cancel, simplify the radical can cancel, and here is our 4th scenario. So here I notice the radical itself is actually a perfect square. So that can just become a 5. Okay. Now this one, well, it looks like I'm kind of done, right? But I actually now can take it one step further. And I can write these because everything's rational now. My radical is gone. I can do 3 minus 5 over 6 and 3 plus 5 over 6. So this simplifies down to negative 2 over 6, which is negative 1/3. And this simplifies to 8 over 6, which is 4/3. So when the radical goes away, you can't just stop. This is not a simplified answer. That's like equivalent to telling me your final answer is 2 plus 5 when you could have just told me your answer was 7. Okay? You need to take it as far as you can go and give those simplified answers.